Hello, this is Nikki Jackson from Southwest Tennessee Community College, and I'm going over several examples from Self Check2 from Math 1710. As you can see, I have the calculator out and about right now, and this would be a good time for you to take yours out as well. I'm a visual learner, so I'm going to try to show you exactly what I mean by this. So one of the things that we're doing is looking for vertical isotopes. So hopefully you got your calculator out already. And here's what we're looking at. The example provided is x plus 3 over x times x minus 6. In case you don't have your calculators, one of the ways that you can do it manually is look at the denominator. Notice how your denominator has both x and x minus 6. So we're just looking at that by itself. If you let the constant x be 0 and then solve for x and x minus c, you know that your isotopes are dealing with 0 and 6 as indicated right here. But the question is, what do we mean by vertical? Well, if we're dealing with graphing, vertical is indicating by your y-axis. So here's your graph. Once you cut your calculator on, you're going to hit the y equal key. This window pops up. Because there are multiple items in each part of this in your numerator and denominator, parentheses are required. So now we got parentheses x plus 3 divided by, open parentheses, x, open parentheses, x minus 6, and close it twice. Hit enter. And now we're going to graph it. Notice how you have graphs on the left, on the right, and then under the x-axis. Because we're looking up and down, which is vertical, notice how you have your vertical isotope at 0. And right here, you can't see it, but it's like an imaginary vertical boundary right here at positive 6. That's one way. Another example, which has multiple parts, is given right here. So you can only see bits and pieces of the actual problem. Let me inch it up just a little bit so you can see everything. One of the things it's asking for is asking for the symmetry. So notice how right here on the side that I said write it out using your calculator, which is, again, I'm a visual learner. So if we're doing that using the calculator, we're going to put it back, hit clear, hit your y equal key, hit clear again because we just used it. For your numerator, you're going to have 5. Divide it 5. For your denominator, make sure you use your parentheses because it's more than one term. X squared minus 9. Close your parentheses. Hit enter to lock it in. Now graph. Now notice, if you were to flip this along the x-axis, which would be right here, it'll look kind of strange because your things will be going in opposite directions. These will be going downward and this will be going upward. However, if you look at it from y symmetry, meaning that you fold it in half, the two lines on each side were actually meet, even though those are several lines, but they will match up. Therefore, your symmetry is going to be on your y-axis. So, oh, also notice how it does not intersect or either cross the x-axis. Therefore, there's no x-intercept. So it's just merging, it's getting closer and closer and closer, but it barely touches it. And we can't see that because we're not able to zoom in. Now, let's find our vertical isotopes. So if you're looking for your vertical isotopes, once again, look at the denominator. So your denominator is dealing with x squared minus 9. So I quickly sketched it out for you. You have x squared minus 9 equals 0. X squared equals 9. So take the square root of that. That's going to be plus or minus 3. So your answer is going to be negative and positive 3. So now you have your vertical. Your next part is find the horizontal. Well, your horizontal is going to be 0. And once again, we're going to look at our calculator. You can see vertically, you have the -3 and the +3. Horizontally, you see how all three of these never, ever, ever touch the x-axis. Therefore, x is going to be 0. That represents your horizontal. For y equals 0, y equals 0. Now let's fill in the blank for these. What that means is that we're now going to substitute -8, -4, 0, 4, and 8 into this equation to see what we get. Well, if you look at it visually, know how there should be the exact same thing because they're mirror images of one another. One might be negative, the other one might be positive, and vice versa. So once we do that, we're going to fill in the blanks with them. I'm just going to do the first 3 numbers for you. So for the first one, and again, my apologies for any mistakes. You see that I'm human too. I tend to make mistakes and don't want you to always to see them, but hey, that's life, and please forgive me for making those mistakes. But back to this. Since we're doing -8, -4, and 0, I substituted those values in. So right here, we got 5 over 55, that's 1 over 11. Then right here, once we simplify it, it's -5 over 7. And right here, we got 5 over 9. Then you can continue on to substitute for 4 and 8. So make sure you pay close attention to what's being substituted and how you do that. So that was filling in the blank for that example. When it's your turn to graph, make sure you pay close attention to the graphing tools on the right-hand side. Moving on, we have an example similar to this one. Now this is dealing with an inequality. Hence you have your brackets, which is given to you right here. Now what we're going to do is look at these as separate entities, which are your numerator and denominator, because they can go in opposite directions. So once you do that, you're going to solve for x for your numerator, which is x is 3. Then you're going to solve for your denominator, and x is going to be 5. But since these are two different entities, one is going to be negative infinity and 3, union 5, and then positive infinity. Now the reason why they're doing that, remember, this is a fraction. So let's show you what's going on. So go back to your calculator, hit y equal, then hit clear. For your numerator, do x minus 3. Your denominator, do x minus 5. But it's not 5. Now graph. So notice how when you have your asymptote right here, positive 3, it's coming from the negative direction. And then when you have your asymptote at positive 5, it's going into the positive direction. Therefore, that's why you have the negative infinity union 5 and positive infinity. For another example, it's asking you to find the horizontal asymptote. Well, here's the reason why there is no horizontal asymptote. One of the general rules that's provided to you in your notes is look at the degree for your numerator and denominator. So your degree for the numerator is 3, because look at your exponent. Your degree for your denominator is 2. Since the numerator degree is higher than the denominator degree, you have no horizontal asymptote. Which leads us into the next example. Once again, you still have a fraction, but look at the degree, aka your exponents, for your numerator denominator. The denominator's degree is greater than the numerator. Notice how my little scribble is, because you have 1 for your exponent here, and then 2 for your exponent there. Therefore, it is assumed that you have 0 for your horizontal asymptote. Lastly, we have, well, not lastly, close to the last, 6, you actually have your graph provided for you. So be careful in what it's asking for. It's asking for as x approaches 2 in the negative direction. So here goes 2. Notice how you got your positive 2 right here. And we're going from the negative direction. That's what that little negative indicates right here. What direction is your f of x? So we're going to say infinity. And the reason why we're saying positive infinity, it just keeps going and going upward. You can also see that for right here, for your positive, negative 2, which is another way of saying it. So be careful with that. More details are actually provided for you. Because I would like to say, is that 2? Is that 1? No, that's 2. I said that right. I was just seeing if that was negative 2. And it's not, that's negative 1. So as x approaches 2 in the negative direction, it goes towards positive infinity. Then number 7, find the domain. You may recall in previous lessons that the domain is pertaining to the x-axis. Well, what we're going to do is look at your denominator. So given to you, if you let your denominators equal 0, what does x have to be? So in this case, x is going to be 1. Notice how it cannot be 0. And then x is going to be negative 5. Therefore, your domain cannot be those. So though this is a shorter video than normal, please make sure you pay close attention to the lecture videos posted in my Labs Plus for Math1710. And I look forward to you again. So thank you, learners, gentlemen, individuals. Continue to be safe.